After having learned about the methods of preparation of chlorine and the physical properties of chlorine, it is time for us to learn the chemical properties of chlorine. Part 1. Now first is combustibility. Chlorine is neither combustible nor is a supporter of combustibility. Second, combination with metals. Now Na plus Cl2 gives 2NaCl, Ka plus Cl2 gives 2KCl, whereas Ca plus Cl2 results in the formation of CaCl2. Now when we heat iron with Cl2, it gives ferric chloride, that is FeCl3. Now Al plus Cl2 gives AlCl3, that is aluminium chloride, whereas copper plus Cl2 results in the formation of CuCl2, that is cuprous chloride.
All victories of India.
We have reaction with water. Cl2 when reacted with water results in the formation of HCl and HOCl. HOCl is called as hypochlorous acid. This further decomposes to give HCl and O2. It is because of this that chlorine acts as a powerful bleaching agent as well as an oxidizing agent. Next up, we have its combination with non-metals. First, arsenic plus Cl2 gives us AsCl3, that is arsenic chloride. Antimony plus Cl2 gives antimony chloride, that is SbCl3. Next, sulfur plus Cl2 gives us S2Cl2, that is sulfur monochloride. Next, P4 plus 6Cl2 gives us PCl3, that is phosphorus trichloride. When more chlorine is used here, it gives us PCl5, that is phosphorus pentachloride. And also, boron plus Cl2 gives us BCl3, that is boron trichloride. Going ahead, let us talk about its affinity for hydrogen. Now H2 plus Cl2 gives us HCl. Now C10, that is turpentine oil, when treated with Cl2 gives us HCl and 10C. If you look at the second reaction, it takes away H from C and forms HCl and leaves carbon behind. So the next property that is reaction with ammonia. Now Cl2 when reacted with 8NH3 gives NH4Cl and N2 gas, whereas Cl2 with lesser amount of ammonia, that is only NH3, gives 3HCl and NCl3, that is nitrogen trichloride. Moving ahead, reaction with CH2. Now CH2 plus Cl2 gives CCl4 and we get S2Cl2, that is carbon tetrachloride and sulfur monochloride. This S2Cl2 when further reacted with CH2 gives us CCl4, that is carbon tetrachloride, and gives out sulfur. Moving ahead, let us have a look at the bleaching action of chlorine. This we've already seen before, that Cl2 when treated with water gives HCl and HOCl. HOCl further breaks down to give HCl and nascent oxygen, which we can directly write as HCl and nascent oxygen. So when vegetable coloring matter is treated with nascent oxygen, it gives out colorless matter, that means it gets bleached. Now chlorine is used to bleach cotton fabrics and wood pulp. It cannot be used to bleach delicate articles such as silk and wool, as it destroys them and is too powerful for them. Now next up is the oxidizing nature of chlorine. Now FeSO4 when treated with H2SO4 in presence of chlorine gives out Fe2SO4 thrice plus HCl. Here Fe2 plus in the reactant part gets oxidized to Fe3 plus in the product side. Now Cl2 when reacted with Na2SO3, that is sodium sulfite, gives Na2SO4, that is sodium sulfate, and NCl. Next, Cl2 when treated with H2S, it gives out sulfur and HCl. That means H2S when S gets oxidized to give sulfur. Now Cl2 plus SO2 and H2O result in the formation of HCl, H2SO4. Here S gets oxidized from +4 to +6 state in H2SO4. Next is the reaction with alkalis. Now Cl2 plus NaOH, that is cold and dilute, it gives out NaCl, and along with that we get NaOCl and H2O. Next is Cl2 when treated with CaOH twice under cold conditions gives CaCl2 and CaOCl twice, which is calcium hypochlorite, and we get H2O. Next, the Cl2 when treated with NaOH gives NaCl and NaClO3 plus 3H2O. This is under hot conditions. Now CaOH twice when treated with Cl2 under again hot conditions, it gives us CaOCl2, that is bleaching powder, and H2O. The COCl2 is called as calcium oxychloride.